Working principle of the hydraulic torque converter. The hydraulic torque converter consists primarily of three components: the pump impeller, the guide wheel, and the turbine. Pump impeller. The pump impeller is integrated with the torque converter housing and is radially equipped with numerous twisted blades inside. The torque converter housing is connected to the engine flywheel. Guide wheel. The guide wheel is located between the pump impeller and the turbine and is mounted on the guide wheel seat, which is connected to the torque converter housing. It also consists of numerous twisted blades, typically cast from aluminum alloy. The function of the guide wheel is to increase the torque of the torque converter under certain operating conditions. Turbine. The turbine also has numerous blades in its structure, but the twisting direction of the turbine blades is opposite to that of the pump impeller blades. The center of the turbine has a splined hole that connects to the input shaft of the transmission. The pump impeller and turbine are installed opposite each other, with a 3 to 4 mm gap in between. The blades of the three operating wheels, pump impeller, guide wheel, and turbine, form a closed-loop oil circuit during operation. The power from the engine is transmitted via the ring gear and pump shell to the pump impeller. As the working fluid enters the rotating pump impeller, it flows outward along the pump impeller blades due to centrifugal force. The fluid exits from the outer edge of the pump impeller blades, strikes the turbine blades, and causes the turbine to rotate, thereby driving the turbine shaft to output power. After exiting the turbine blade edges, the oil flows toward the guide wheel. Since the guide wheel is fixed, it imparts a reactive torque to the working fluid. This reactive torque combines with the torque imparted by the pump impeller, resulting in a greater torque output from the turbine than the engine's input torque. This torque multiplication allows the loader to automatically adjust its speed and traction according to road conditions and resistance during shoveling. When resistance increases, speed decreases, and traction increases. Conversely, when resistance decreases, speed increases, and traction decreases. Speed and traction can be smoothly adjusted within a certain range using the throttle, ensuring steady moves without impact. To ensure the safety and reliable operation of the torque converter, two control valves are installed externally. Inlet valve controls the oil pressure entering the torque converter. Opening pressure 1.47 to 1.86 MPa. Outlet valve regulates the internal pressure of the torque converter to ensure it remains filled with oil. Opening pressure 0.25 to 0.35 MPa.